All right. So today we will wrap up what we learned. Well, actually, not wrap up in the sense of review. We're not reviewing. We're just doing recap on Rust, right? So the first recap is: can someone tell me what's wrong here? This is the same example I have about 3 weeks ago. So can someone tell me what is wrong here? And the hint is on the highlight part, obviously. So can someone tell me what is wrong? Data risk, right? In what sense? Can you be a little bit more detailed? Like what would cause the data risk? Accessing JPEG. All right. So you are trying to access JPEG, right? And you increment it, which means you're writing to it. Why data risk could have happened here? So when you do a map, anything that would trigger this data risk, why is multi-threading can lead to this particular data risk versus single-threaded program if I do the map one item at a time. So let's say you have two threads, right? So because the answer here is actually correct already. One of the thread would access JPEG, trying to write to it. The other parallel thread access the value while the first thread is still trying to modify its own version of JPEG. So you don't see the increment, right? So at the end of the day, let's say there are two items. You are ended up with JPEG equals 1 because both of them would see read JPEG. What's the value of JPEG? 0. Okay, I'm going to increment that, right? So you get incorrect value. So how do we solve this? You can use a lock, obviously, right? So that's a great solution. The other solution is use atomic operation. This is a more open-end question that I want you to think, right? So I'm not going to directly give you the answer right now, but let me ask first. What would be the trade-off between a lock and an atomic operation? To recap, right? To recap, when I apply a lock, what happened? If I apply a lock to a line of code, what would happen? No one can edit, right? When you see lock, think of the bathroom example, right? Restroom. I have a lock to the restroom. Can someone else come in? No, I will get to do my own business until I'm done and unlock it, right? How about atomic operation? Can two things come in and run their code? Yes, right? But what would happen if data rest happened? Yes, it would choose one operation, commit, finish that, and then what would happen to the other? It would wait and redo, right? It would wait. I can't do this, so I'm gonna wait, and then I'm gonna redo this, right? So which one is good? Well, I mean, what's the trade-off? Right? What's the trade-off? Which one guarantee for sure only one thread would actually doing things in the lock? Or dealing with the resource, actually, dealing with the shared resources that involved in a lock, right? So lock would prevent anyone else from accessing the resource. Right? So you get that? Lock would prevent anyone else from getting the resource. How about atomic? Can two things get hold of the resource? Let's say there are two things. I want to read, both of them want to read the resource. Is that okay in atomic operation? Yes. Right. So the benefit of atomic is if violation doesn't occur, you're fine. Which one is more relaxed? Which one is more restrictive? Atomic is more relaxed. Lock is the way I think about it. Atomic is more relaxed in the sense that, well, if nothing happened, we're fine. We'll keep going. If something happened, we're still fine. We'll make sure it's safe. Lock is a little bit more restrictive. I'll ensure nothing happens, right? I'll ensure nothing happens because I'm going to put a lock on it, right? Uh, Hopefully you see this example and you see the trade-off, right? You see the trade-off. What would be the downside of atomic then? Can anyone guess? It might be slower. Actually, that part might or might not be true. But think about it this way: if I use a lock, who's responsible for everything? Who's responsible? Is it the programmer or the computer? The programmer, right? The programmer has to just put in the lock and everything will be handled. So it's simple in terms of the hardware support. Atomic operation, or I mean hardware support or the support from the language, right? The language can support this too. How about the atomic operation? Who is who's gonna have an easier job here? The programmer again, right? It's like, yeah, atomic operation. If something happened, I would assume it's correct, right? But think about it this way: then who is responsible for ensuring correctness? It can be the language, it can be the hardware, it can be the combination of both, right? This is another, I guess, discussion that I want you to think a little bit and see like, hey, I mean, there's tools that you can use, right? It comes with the trade-off that something is strictly beneficial because things in the hardware or in the language or in the compiler or in the system software. By when I say system software, I always mean DOS that enabling you to do this cool, fancy, fast thing, right? But if you ended up with something simple like a microchip that doesn't really handle a lot of fancy operations, what do you do? So, what would be your last resort? So, let's say I have a program that cannot use atomic operation. What can you do? You use a lock, right? So, think of it as these are different tools. What I'm trying to lead during this discussion is basically, hey, you have tools. These two have this advantage. These two have this advantage. Pick the right tool, right? So basically, think always consider what are the tools that you have for your solution, and think about which tools that you're gonna use, right? Which tool that yeah, that's sorry, you are going to use. What's the ownership rule? It basically means that every single value would have a single owner at any given time. And why is that good? So I'm gonna pause here. I'm gonna wait for your answer. Why is it good? Okay, you're getting there. Memory thingy. So can you expand on? Can someone help expanding on the thingy? Unusual rights, right? Uh, so let me kind of declare what it means a little bit more. I would say expand, right, on the unusual rights. It's basically tell who gets to modify the value, right? Who gets to actually use and modify the value. Think of it as this is physical item in your world, right? You can have, say, I have a mug for my coffee, right? Who would be able to use this mug now that I use it? Which still have coffee left, so I'm gonna sip it. And can you tell me who can use it? Me, right? It would be kind of bad if suddenly my cat turns around and drink, which sometimes they do. But that's not proper, right? Because I own the coffee mug and I own the coffee inside the coffee mug, right? So what can you do if you want to use a value that you do not own? You need to borrow them first. So this is the ownership system in Rust. You borrow the reference. And if I say, hey, I'm gonna sell this coffee mug, I'm gonna sell the coffee mug because I own it, I can sell it, right? What happened to the borrowed value is the value would not be able to be referenced anymore, right? So to expand on the unusual write slash memory thingy, right? Is it more of the who get to be able to use the value rather than whether who gets to write, who gets to read? It has the element of time, right? It has the element of time. At this time, who get to use it, right? And to change the value, you change your value. You need what we call the exclusive access. Exclusive access. If the value is read only, if I say, hey, this value, no one would modify it, how can I tell that the value is going to be read only? Is that immutable or is that mutable? So immutable would enforce I cannot modify it, right? So if the data is immutable, how many entity can borrow that value at the same time? Many, right? To make sure, oh, everyone can read it. Everyone can read it, and it's going to be safe until I declare, hey, I am going to destroy that particular value, then no one can read it. Right? So the ownership rules still work, and it worked well. To be honest, it worked quite well because many people can use it. Yay! So you can have parallel operation. Right? If you need to change the value, if you need to change the value, that's when you only can have one owner, right? And when you have function call like this, let's say I say let name equal format. What's wrong with this? Why does it violate ownership rule? The first function call helper, right? So when I declare name, currently the first line function main has the owner. Basically, it can do whatever with name. Then the helper function call. These first call, I pass the ownership. I pass the ownership because I'm not lending, I'm not borrowing. No one's borrowing anything. When you have this kind of function call, the ownership of name get passed to helper. Helper finish its call. What happened to name? So helper is something like this. What happened to name at this line, right here? Remind you, name is now owned by helper. And helper gets destroyed, right? So when you finish a function call, think of it this way, you get destroyed. What would happen to the object I own when they get destroyed? It got destroyed too. It got thrown away, right? So no one owned name anymore. So the second time you call helper name, what happened? Oops, this thing doesn't exist anymore. So you're gonna see an error, right? So be careful when you compile things in Rust. If it says, hey, it's violate ownership rules, remember this example and trace through who owns what because it can be annoying. So this is a fair warning for you. This can be annoying. Borrowing. So what does borrowing mean? It basically means I'm gonna transfer the right to use to someone, right? And in Rust, remember we need the ampersand to specify the item that you want to borrow. For example, with the same example, almost the exact same example actually. It means that now R borrow name. So whoever is using R will borrow the data in name. So this is fine, right? Over here, helper function, see the difference. I say, hey, it's gonna be a string that is borrow. I'm gonna borrow R. I'm not gonna directly take R. I am just borrowing it, right? So the ownership still is in the call function, right? Lending, what is lending? What's the difference between lending and borrowing? Borrowing, it means that I'm gonna borrow something, right? Lending means that the owner say, hey, someone can take this. It's fine. I would lend it for you. So if you want to do lending instead of borrowing, you can do something like this. Put the ampersand in the function call, say, hey, helper, take this name. It's fine. I'm gonna lend it to you. I'll still own it, but you can use it. And then inside here, put the ampersand in front of the data type to say, hey, I'm borrowing this. Someone is lending this for you. All right, we are close to the end. Actually, as promised, this will be a short lecture. Be more of the demo, right? Types of ownership. If you are the owner, you have full control. Sorry. I'm so sorry. You have full control over the object, right? It gets free when you finish using. A shared reference means that you have many reader, no writer. There's a performance benefit in hardware because a shared reference can be run in parallel. Mutable reference, no other reader is one writer. The difference here, the keyword MUT. All right. Mutable reference creates serialization. Right? So this is kind of like the recap of what we've seen so far with some deep dive into some example. Hopefully you remember. Sorry, I think I need water soon. Hopefully you remember what we covered so far, right? Because assignment 3 will have these things. All right. So the next thing I want to make sure you are aware is in Rust, many of these checks are done during a compile time. So when I say the word compile time, anyone want to take a guess what it means? What does compile time mean versus runtime? Don't think too hard, guys. Please don't think too hard. What's the difference between compile time and runtime? So yes, the compile time means that this is done when I compile the program, right? It's not the time to compile the code. It's more like this is done when I compile the program. These techniques, let's say, if I have the word, let's say, techniques A is a compile time solution. That means that this particular technique is applied. It's applied when I compile the code. How about runtime? When I say it's a runtime technique, what does it mean? This is applied when I run the program, right? So you see the difference. Compile time solution is something that when you compile the program, you apply the techniques. Runtime means that if you run this program and apply this technique, it would get applied when you launch that program while it's running. So what will be the trade-off? Let me again open it up the discussion. Today we will do a lot of discussion. What will be the trade-off here? let me ask you this question first. If I run a program, if I run a binary code, because every program that you run is just a bunch of ones and zero, right? It's just a bunch of one and zero. Can I see the code when you run the program? How about when I compile it? Can I see the code? Does the compiler actually look at the stare at your code and say, oh yeah, this convert to this particular assembly, right? So the first difference is the ability to actually see the source code and understand the source code, right? Think of it this way. Compiler, one of the main tasks is understand what you are writing inside a program, right? So that it can write the correct assembly instruction that represent exactly what you are trying to do in the program. So compile time solution would get to see the code. What else? If I compile into some .exe file, right? I use some compile time solution. Then I give this file to your friend. Does the same technique that's being done already apply when do your friend run the code? So let me repeat the question again. If I apply a certain compile time solution, like let's say I use Rust, right? I use Rust. I somehow get a binary out of Rust compiler. I give the binary to your friend, assuming that it's similar computer, but it's a different located at a different physical computer. Is that technique being applied on a new computer? Yes, right? Because it's already in the assembly. How about runtime? How about runtime? Who needs to enable that technique? It will be computer by computer, right? It depends on the computer itself. How about the second example? If I apply certain runtime solution to the OS and I run 10 different programs, is it going to be applied on all 10 different programs? The answer is likely yes, right? So that's why, right? That's why when you try to fix or to improve certain thing, you can apply this at the different phase, at the different compute stack, right? With Rust, we say, hey, compiler is a perfect for this. It's a perfect, it's a perfect level to do this. Why is that the case? You program in parallel, right? So you can apply the read and write locks during the compile time, right? You can apply read and write locks during compile time. What will be the benefit? So first of all, you have the knowledge of the code, right? Why is that the case? Why is it so clear? Okay, do I have to apply the write locks over here? Why is that so clear in Rust? In Rust, why is it so clear which variable would get modified? The ownership and what keyword does say this variable is writable? Yes, right? You specifically say MUT. Whenever you say MUT, what does it mean? It's mutable. So with the combination of ownership system and the keyword mutable, what can I tell? What can I tell? I can tell how many people would get to access this thing, right? And whether it's safe to do that or not. So you can apply the read and write locks by just staring at the code, right? You like from the compiler point of view, it processes the code. I'm like, oh, okay, I need to apply the read locks over here. I apply the write locks over here. It's clear because the programmer specified that. The programmers do that specification. It put in the keyword MUT, it put in the ampersand to say who owns what, right? So this is perfect to do in a compile time. This guarantee that write logs is going to have a single writer to the data at any given time, right? And surprise, this concludes the class. This concludes the class, right? So that's it for the I would say the semester. I've been having a lot of fun teaching. I hope the topic is not too confusing. If anything still confused you, we still have a week left. Next week, I'll do two things. The first thing is I'm gonna show you some demo on code that runs on OpenMP, code that runs on your GPU. Uh, Depending on your own computer, you might be able to run these codes, you might not. It depends on your setup. So I'm gonna try to run it and show it to you, right? I'm gonna show it from here, from the lecture point of view. If you would like to try it on your own and would like to say, hey, how can I set this up? I want to try, I want to play around with this. Please contact me, right? So I can help. Uh, the other day on Thursday, I'm gonna do a review of what could go onto your final exam. All right, what could go onto your final exam. All right, so the remaining of this class, I'm gonna ask you to do a demo. So this is another in-class exercise, to be honest, but this is an in-class exercise where you have to actually apply and finish and demo by hopefully the end of not, if not this class, if not this class, show me that it works at the end of, I would say Sunday. Is that okay? It's not hard. I give you every single line of code. I'll give you every single line of code. There's only a few things you have to modify. All right. But this is relevant to your assignment. And I'm definitely give a credit to Ajahn Kanat because basically he's the one developing the code. I took his material and I took this particular example too. So the thing is, this particular task is I would like to get all the links of a web page, right? So let's say I go to mahidol.ac.th and I want to write a script that would get all the links available on the web page. So if you think about it, there are three goals. First, I want the link. That's the first thing. I want the link. The second goal is once I have the link, I need to make sure they are unique. In other words, there should be no repeated elements. Every single element in the vector that I'm gonna return should be unique, and then return that vector. It's as simple as that. Any questions about the goal? You go to a website, you gather all the link. If there's repeat elements, get rid of that so that it's just unique links, and then return that vector. Now I'm gonna go to Cargo.toml, right? So what is Cargo.toml? Basically, this allows you to specify a certain package. Anyone want to take a guess what's the package that we use right now? Yep, package. So the package, so Cargo.toml allows you to specify certain cargo. What is a cargo in Rust? Anyone try it yet? So if you Google Rust cargo, yes, it's basically like an open source project that people release and you can use, right? So this basically would go and get the package called, I'm gonna parse a web page, right? And I'm gonna get this particular specific version, right? And I'm gonna specify dependency. Let me actually ask you this. This is not relevant to this class, but whenever you see the word dependency, in this case, anyone want to take a guess what does it mean? Exactly. It means that, okay, I'm gonna also make sure that these things are installed and it should have these versions. This is something that will be so useful when you go forward and actually work as an engineer or computer scientist. Why is that the case? How many times you have to install new fancy tools? every time, right? How many of you actually start to run into this dependency problem on like, oh, this require Python 2 instead of Python 3? You start to run into that soon, right? If you haven't run into that yet, you're gonna run into that in the future, I can assure you. So whenever you fail to build any tools that you download, first of all, my first recommendation, double check the dependency. The tools that you download will tell you, okay, this particular tool requires X, Y, Z, this version, this version. Make sure it's those version because it will make your life a lot easier. Anyone want to take a guess why does that exist? So let me rephrase that question. Let's say you are running program on Rust, right? That's one thing too. So let's say you run a program on Rust. What version of Rust you're using? Let's say it's version X, right? Let's say it's version X. 5 years later, is it gonna be a guarantee that version Y comes in and it's gonna still run your code? Is that the case? No. So that's why dependency is important in that case, because sometimes your code works on one version, the developer doesn't test it on the other version yet because people have limited time. Surprise, we haven't invented time machine yet, right? So it means that you would test your particular setup as many different versions as possible, but you have limited time. So they only know the thing that they have tested on. Right. So if you look at the dependency, it should tell you, okay, it works with this version. It requires these particular packages. Right. So hopefully these are more clear. And here are the code, and I'm gonna explain the code. Okay, I cannot progress. Okay, here are the code, right? It's called a function called web demo. Feel free to copy and paste it on your own demo time, right? This will be up next. So I'm gonna use a packet request to get my URL. Right? I'm gonna use a packet request to get my URL. The URL is the web page that I want to crawl to get the links, right? Then this question mark is just to make sure that that URL exists, because if it doesn't exist, it's going to throw error so that we can return a request error, right? That's what the question mark is for. The question mark is say, I guess it works. If it works, I'll put that in the body, in this variable called body. If it doesn't work, I'm going to return error as defined by the function call. All right, so that's our first line. If you're with me so far, basically the second line is, I'm gonna also then select the document. And basically I'm gonna convert this URL, that URL request that I just sent into a string so I can parse them. Basically, just convert the web page into a string format, right? Then I'm gonna get all the links into a vector format by find name and apply the flat map. What does flat map do? Anyone remember things that we did in assignment 2 flat map? So what does flat map do? It applied a function like a map, but it can be applied on a uh, uh, nested object, right? Why do I want this href? What does href stand for in HTTP uh, language? Is HTTP a language? Is it a language or it's just protocol? What is href? Hypertext, right? It means that that's the link that we want to gather. So it identify all the strings, like anything that come with the href, that's our link. So I'm gonna collect them, right? I'm gonna collect them. I'm gonna print them all. I'm gonna print into the function, the variable called link, which is essentially our vector, essentially our vector. So that would give you every single link in a page, right? So any questions about this code? Because demo time. So from the previous page code, you can see the PDF from our Canvas website. Each one of you would take turns showing me the result on Discord, right? So let's stay on Discord. If you want to finish early, do it right away and yell at me, "Hey, Ajahn, I'm done. Here's the result," right? Just tell me your name so I can check that you're done. Work through the demo and let me know if you have any question. And because we have 1 hour and 15 minutes, a little bit less than I expected, but still enough time for assignment 3 of this hour because that's well. When you create a when you create the project, Cargo.toml would be there, I think, along with your project. So if you have an IDE or when you run a program in Rust, this Cargo.toml, I think it's generated, if I remember correctly. All right. So I'm gonna switch over to Discord. Let's do also take a break, maybe 10 minutes. We have a plenty of time. You can start right now. Uh, we can take a 10 minutes break. I'll be on Discord at 12:55. Okay, I need water. Really seriously, I need water. I drank too much coffee. So I'm gonna be back around 12:55 and I'll be on Discord. All right. Make sure you get checked. Make sure you get checked. If you're not done by the end of this class, if you're not done by the end of this class, let me know. Let me know so that I can check you off at a later time because we still have 2 more classes, right? So we can check off at a later time too, but you need to get checked off. Right? You need to get checked off. This would allow me to make sure you, first of all, you have a setup that run Rust, you have a setup that also compile the code correctly, and you get to run something for sure for your assignment 3. All right. Any other questions before we adjourn and move over to Discord?